Okay, thank you everyone. If you can take your seats, we're ready for our third session here in Edward Room 5 and 6. As I've said at the start of the other presentations, if you go to slido.com and use the code BASECAMP26, you can enter your questions in on Slido. We're about to hear two presentations from Peter. At the end of that, we'll call Anna back to the front and we can do Q&A for the whole of the 4 sessions. Now, I'm not supposed to have favourites, but this next problem statement is one that I'm very keen to hear about. It's all about robots, and to talk about it more, I'll pass over to Peter. Please welcome to the stage.
Right, good morning everybody. I'm Peter Lang, been working with UK Power Networks and its legacy companies, not quite as long as Cliff has, but I joined the electricity industry back in 1990, so I had quite a bit of experience, operational experience, working in outage planning, so I know exactly what Anna was talking about. We all remember Ella. And I'm now wishing to present two problem statements, which I do hope there's somebody who'll be able to help me. But a little bit about UK Power Networks. We look after London, the South East and the East of England. We serve, I think the figure is about just shy of 8.5 million customers. And we have obviously a large number of generators connected to our networks, as well as customers who are now behaving differently to what they used to. But one of our challenges is how do we ensure we maintain our substations such that we have that resilience. You can have all these wonderful computer systems which can do the calculations, but if you've got some budlia and it's grown up between the equipment, it takes that equipment out pretty quickly. I don't know if any of you saw the news yesterday, but it appeared that there was a plane crash where a light plane landed, and there was it appeared to be a parachute in the overhead lines. I don't know the details, but they are the things where you can't plan, but you've then still got to be able to maintain that resilient network. So I'm wittering a bit, so let me move on to our problem statement. Right, so when the assets on our network, we know that there's a problem with them. For example, a current transformer, a voltage transformer, a cable bushing. It doesn't matter what it is, a piece of equipment, and we know that there's a problem with it. You can't just say to staff, well, it's okay. No, we know there's a problem with it, but you can go in and do some switching in that area. What we want to do, what we need to do is we establish these risk management hazard zones, which says, yeah, you can go in for a finite amount of time, typically 10 or 15 minutes. Now, somebody has done the calculation saying, right, yes, we know that there's a problem, but the likelihood of somebody being in the substation at that time when that piece of that asset fails, because when an asset fails, it scatters porcelain or other components across the whole site. You don't want to be anywhere near it. And no, it's not only ourselves, it's all the electricity companies and the National Grid Transmission and the Scottish companies as well. We build a barrier, and that barrier may be in the form of containers. So you've got your Lego blocks, and you build a barrier such that if that event did occur, the neighbours who are across the road are not going to be affected. But equally, we're going to be in a situation where we've still got to work in that substation. And as I mentioned, vegetation is a big issue. Plants grow in our substations, and we've got this lovely environment, which is a shingle beach which has been designed in such a way that we manage step potentials and things like that. But we need to be able to allow our staff, or what we want to do is avoid having to put our staff in those areas where they're doing vegetation management. And the photo here is one of our main substations in Crawley and Manjula. You can tell me where this one is. The situation is you can't have staff going around spraying weed killer around and removing the weeds in an area where you've got one of these risk management zones, because that was the whole point of establishing the zone in the first place. So one of a human is very good at identifying, look, there's a concrete path, I can step over that and onto the shingle bead. The surface area is very unstable, but that vegetation can grow very quickly. There are, I'm forgetting the name, but plants like buddleia will grow this high in a year. So if you haven't got on top of it, it becomes an issue very much quicker. And just to give you an idea, here is another grid site. You can see the shingle, but also you can see the vegetation. In that instance, it's not too close to any switching or switches, but clearly, just because it's in one corner doesn't mean it could be elsewhere. So the challenge I'm asking you is, can we have, as Dan was saying, a robot, something which can allow us to deliver it to site, set it going, because we don't want to sit there and drive it round the compound. Almost a case of you set it going and it tells you where it's been. It tells you, I've cleared these areas, I've applied the weed killer in these areas. And I was speaking to somebody earlier, and he said, well, what you want is something that comes out of robot wars. But what we want is something which manages itself in such a way that if it does need to have a recharge, it gets itself back to the charge point, and say it gets set up on the Monday, picked up on the Friday, moved to another substation for the following week, and in effect you've got a team who are moving these devices from one substation to the next without having to be in that substation, because clearly we don't want to be anywhere. You don't want to be in a substation unless it's absolutely necessary. So what have I got written there? I think I've covered the real challenges, and the reason why vegetation is so important is all about security of supply. So I don't think this is a problem just for UK Power Networks. I think it's a problem for all the electricity companies. So I think that one concludes my first problem statement. Oh, hang on, we've got a little bit more. Yes, so this is where I thought I'd get to. So a typical substation where you've got buzz bars, you don't want to be lifting any equipment which is in a way that's going to interfere with any of the equipment. So it needs to be able to identify where it's going, identify the vegetation that it's going to be clearing, applying some form of weed suppressant to ensure that the weeds don't regrow too quickly, and we recognise that there are going to be some locations that it can't get to. But as long as the system tells us it hasn't been to that particular corner because there was a stumbling block of some sort, at least we know that there's areas where we need to find the solution. So we are looking for ideas. I'm Peter Lang, and really, if there's any questions, once I've finished our next presentation, Anna and myself will be taking those questions and hopefully be able to provide you with some answers. Thank you.